Hey everyone, we are about to start the next chapter on graphing and looking at properties of graphs. And if we think back to what you were doing in Math 20, if you're given a function x cubed plus 6x squared plus 9x plus 2, you were concerned about where the function was positive, so where the function was above zero, or where the function was negative, or where the function was below zero. So that was kind of like Math 20. And when you're doing that, I think you used interval notation to kind of talk about reads and those things. So what we want to talk about though in calculus, of course, is we want to talk about slopes. And when you look at something called the first derivative test, we want to know when a function is increasing or when a function is decreasing. And when a function is increasing, you can see that, just going to get rid of this graph for a second. When a function's increasing, you can see that its slopes are positive. And when a function's decreasing, you can see its slopes are negative. And when a function's increasing again, its tangent slopes are positive. So when we're going to talk about the first derivative test, we're going to talk about how do you know if you're at the top of a curve or bottom of a curve. And we're going to use the idea that when you go from an increasing function, so when you go from positive slopes to negative slopes, you go through a maximum value. Or when you go from negative slopes to positive slopes, again, a negative to a positive, you got to go through zero. So you have a zero slope, so you go through a minimum. And that's what the first derivative is about. So we're going to talk about whether the function has a positive slope, whether the function has negative slopes, and where it has zero slopes. And where it has zero slopes is actually kind of a key property for us. So we want to talk about a couple of things that are called critical numbers. The critical numbers are where you have a slope of zero or where your slope is undefined. And we want to make sure we know how to tell where we have regions of positive slope and where we have regions of negative slope. So our first example we're going to work on is going to be about the first derivative test. And to start the first derivative test, we need to know slopes, and we need to talk about the critical numbers in our slope. So we're going to talk about where things have a zero slope and where things have an undefined slope. All right, so example number one. Step one, I'm just going to use CN for critical numbers because that's what we do in math. We just make things easier. We want to know where we have positive slopes, where we have negative slopes, where we have a slope is zero, where we have a slope that's undefined. Well, this is a polynomial function, so it has no place where the slope is undefined, so the slope is only zero. So again, doing the math, take your derivative, make it equal zero, use some factoring skills. The 3 has nothing to do with being zero, it's just a vertical stretch. Your zeros come from your factors. So if we think about regions then, and if you were to go back and look at the graph we had on the previous part of the slide, we're going to talk about dividing our number line into 3 different regions. We have a region to the left of -3, a region to the right of -1, and the region in between. And again, the reason we have -3 and -1, that's where the slopes were zero at. So where your slopes are zero, you don't have positive slope or negative slope. So what I do to organize my information is as I talk about these regions, this first region is from -infinity to -3, and I got from -3 to -1, and then from 1 to positive infinity. So I've got 3 regions to talk about. And when you talk about regions, again, you're not going to include the -3, you're not going to include the -1, because at those points, the slopes are zero. So the functions, when it's zero, doesn't have an increasing or decreasing. So I put my information into a table. And my regions, like I said, are from -infinity to -3, -3 to -1, and -1 to infinity. So this is like my domain. I've got 3 regions for my domain. I like to put my factors in, x plus 3 factor, x plus 1 factor, into a column. I don't have to factor. I don't have to put my factors into the column. I could put my whole derivative into the column. And I could have gone back and put 3x squared plus 12x plus 9 in here as well, because that's going to have no bearing on whether the slope is positive or whether the slope is negative. And I do a column for slope, and then I do a column for the function. And if we just kind of look ahead for a bit, we'll talk about why these are positive, negative slopes in a second. But wherever my slopes are positive, I know my function's increasing, and whether my slopes are negative, I know my function was decreasing. And again, that goes back to that previous graph. So how do I make my table work? I want to pick a number that's in this area of the domain. So pick a number between negative infinity and negative 3, and it doesn't matter what number you pick. If I pick negative 10, I would go negative 10 plus 3 would be negative 7. So it doesn't matter what number I pick in this region. If it's less than negative 3, if I add 3 to it, it's always going to be a negative number. And if I add a positive 1 to a number in that region, it will also always be negative. If I was to put that number into the function itself, x squared plus 4x plus 3, it would also tell me the slope is positive there. So two negative factors multiply to give me a positive factor, which means I've got a positive slope in that region. When I have a number between negative 3 and negative 1, such as negative 2, negative 2 plus 3 is a positive number, or negative 2.5 plus 3, or negative 2.9 plus 3. They're always going to be positive. Negative 2.5 plus 1, negative 2 plus 1, negative 2.9 plus 1, negative 1.5 plus 1. That's still a negative number. Positive number, negative number multiplied to give me a negative number. If I put a negative 2 in here, I would get a negative value as well. So it doesn't matter how I try and figure out my slope. I know my slope's going to be negative from negative 3 to negative 1. My slope is negative, my function is decreasing. And then the same thing I do in my table. I pick a number that's larger than negative 1. So like pick 1,000 or 1,000,000, or pick 0. Right? And if you go 0 plus 3, that's a positive number. 0 plus 1 is a positive number. If you put 0 in your function, you still get the same, you get a positive number. So I know my slope is positive from negative 1 to infinity. So I know my function is increasing from there. So what the first derivative rule is telling us is if you go from a region of increasing, so a region that has positive slopes, to a region that's decreasing, negative slopes, you pass through the 0 slope, you pass through the critical number. That critical number has to be the top of the curve. So you have to have a maximum at f of negative 3. Again, negative 3 is the number you're talking about because that's where the slope is 0. So your critical number is the negative 3. The other critical number is negative 1. And what's happening at negative 1 is you're going from negative slopes to positive slopes. You're going from a decreasing function to an increasing function. So you're going through the bottom of the curve. So when we're finished, if we think about what we just did in our table, you've got positive slopes, and then you got negative slopes. So when you go from positive slopes to negative slopes, you got a maximum. When you go from negative slopes to positive slopes, you got a minimum. Right? So these are the critical numbers because this is where the slopes are 0. And again, critical numbers are where the slopes are 0 or where your slopes are undefined. So there's our first example. And we'll try and do a few more examples to kind of get things figured out here.